In this small demo, I'll explain how to use the SpotID Leopard individual identification program. Firstly, we have to navigate to the GitHub website, and in it you'll have all of the instructions here. So this video will act as a supplement to that. So now you have two options. Either you download the zip of all the stuff here, or you git clone it, which is what I'm going to show you here. Then you go to a terminal, you go to wherever you want the program to be installed, and then you just go git clone that. It is quite heavy because it has the model itself, which is around 50 megabytes. Once this is done, then we have to navigate to the project itself and install all the requirements. So, well, firstly we have to navigate to and then this is to create a virtual environment. Again, all of the stuff that I'm doing here is on the readme itself. You activate it and then you install the requirements. This should also take around 2 minutes. You have the requirements downloaded. Now, it's very simple. We have to navigate to the interface and just launch the interface itself. With this, we get the hyperlink that is on the readme, and we put it in our browser of choice, and we will get shown this. For the first time that you launch it, you will have to run the model from scratch, and then the second time you can use this that I'll explain later. So firstly, you have to say where you want all of the outputs to be saved. In my case, I'm just going to put it in downloads, embeddings 1. And the path to encrypt images, in my case, it's in the desktop. I'm going to try these ones here. Okay, and now you're running the model from scratch. If you want to check how it's going, you just need to go back to your terminal where you're launching the program for, and it will print all this stuff. Basically, all the background removal, all the steps that are explained in the readme and in the paper, they take quite a while. They take around 15 seconds per image. And then the model itself is very fast. For 500 images, it might take around 20 seconds. So, yeah, the first time that you run it, it'll take a while, but then that's it. You only have to run the background removal and all that just once. So as I said, in the terminal you have all the information that you need to make sure that the model is running. So as I said, it takes around 15 seconds per image. And then you can see in the data folder inside the program all the outputs, so the background removed and all that. But in any case, what you need to worry about, and then this is all the embeddings, is that this landing page gets loaded. In it, you can double check if your leopards are correct matches or incorrect matches. Obviously, there is a confidence, which obviously a higher confidence means that the model is believes that this is a closer match or not a closer match. In any case, the image that is shown first is the closest image in all the data set, the second image, the second closest, blah, blah, blah. Before I show you the functioning of the actual interface, I want to show you that if afterwards we run again the model with a new leopard that you have found in the field, that if you don't need to start from zero, that the model only needs the last image. So it counts all the images that it has, it finds the new one, and it does that. So for example, I have this image of a leopard. I added to the thing I had. I run again the program. I set the embeddings as I had before, and I put the folder that I used before, and that I just added one image. And as you'll see, yeah, found just one unprocessed image instead of 5 that there are in that folder. Now let's see how the program itself works. I'm going to launch it again, and this time I'm going to use the other pathway because I've already calculated the embeddings as I showed before. Here I'm going to load one that I calculated before, which has 520 images. So obviously it would have taken quite some time if I had taken the video. And here we go. So here are the 520 images. They will get shown one by one as anchor images, and then 5 images will get shown as comparison images. The 5 closest ones, as I explained before. So first you have to set your match directory. I'm just going to say it's called matches. This will get saved in the IRP, in the program directory. Otherwise you can set the full path and it will do the same. And the same for the database. This is very important in case you want to open it afterwards. Now, let's say this one I confirm that the match is here. I can zoom in as such, and you can see that this rosette here is here too. So I can confirm it is, I can confirm it is, I can confirm it is, and on and on. In this case, I'm cheating because I can see the ID here, but obviously in your case, it won't happen. And imagine I go to the next one, it continues like this. These are all correct matches, all correct matches, and we continue like this. The program is intelligent, which means that if we confirm a match in one, then when this image here gets shown as an anchor image, then this one won't get shown as a possible one. So you're getting shown the 5 closest images that haven't been matched already. In this sense, your effort is minimized, but obviously at the same time, then the possible correct matches decrease each time. If you see here, this is an incorrect match, obviously, as what's the right side and this is the left side. And this is just because all the ones from this leopard have already been matched. Okay, so we continue. Let's continue. And I'm just going to make another one before I stop. Yeah, okay. I'm just going to confirm these matches. Okay, and now imagine I'm done for now. So I click end session. Okay, now if I go to the matches, which as I put matches directly, that means it's going to get saved directly under it, so an interface. In these matches, already all the leopards that we have confirmed as correct matches get saved in the same directory. In the end, obviously, right now we have lots of leopards here because of the 520 images, we just went through 10 or 12. But in the end, obviously the number of directories will decrease. Okay, and also you have a CSV here, which just shows the path and the leopard ID. There is one last thing, which is, again, I launch the program again, and imagine that we want to start off from where we were before. So we load exactly the same embeddings as I was doing before, but remember that I didn't go over the 520 images, I just went over 10 or 12. Then I set match, I'm gonna set another one, matches 2. But if I want to continue over what I was doing before, I have to open the same database. This is very important, the same database that I created before. So in our case was LeopardDB1. So if it says loaded, it means it's not a new one. Then the second image is no longer the second image in the dataset. It's the second image that we haven't checked in the dataset. So in this case, we don't have to go through the 520 images each time. We just have to go through the ones that we haven't gone through. Okay. And we continue the same. Here is not a match. It's not a match. We've already done these matches, basically. This one is a match. This one is not a match. Already you can see the confidence is very low, but again, we have gone over these matches. And again, you end the session, and the output will get organized the same way that it was before.